To determine if an arc is a minor arc or a major arc, we need to determine if it goes less than halfway around the circle, that would be minor, or more than halfway around the circle, that would be a major arc. If it goes exactly halfway around the circle, we'd say that it's a semicircle. So let's take a look at 3 examples down here for this first circle, and first determine what kind of arc we're looking at. The first segment is labeled RS. Well, with 2 letters, that tells me to go the shortest way possible around the circle to connect those 2 points together. So R and S is going to be that short arc, which is less than halfway around the circle, which means this is a minor arc. I also know it's a minor arc because they only use 2 letters. Minor arcs will use 2 letters typically. Sometimes you may see them with 3, but typically they use 2 letters. Next up, I want to do this 3-letter arc, RTS, meaning I'm going to start with R and end with S, but I want to go the long way around the circle, making sure I pass through point T along the way. So starting at R and ending at S, passing through point T is going to be this arc around the circle in this direction. Because that goes more than halfway around the circle, there's my major arc. And lastly, we have, let me switch colors real quick. Lastly, we have arc RST. Not the same thing. This time I want to start at R and end at T, passing through S along the way. Now that does indeed look like a semicircle, but I shouldn't go just by looks. There's one more piece of this problem that confirmed that that was indeed going to be a semicircle, and that's the fact that RT is a diameter. So that I know goes halfway across the, or straight through the circle, meaning that arc is definitely going to be halfway around or a semicircle. The other part to this question asks me to identify the measure of the arc. Well, the measure of the arc is going to be equal to the angle that I'm looking at, the central angle. For the semicircle, because that's halfway around the circle, I know without doing any work that that's 180 degrees. For my minor arc, I can see that it's the central angle right here that forms it. So that minor arc is going to be equal to the central angle that forms it, so the minor arc is 110 degrees. And then for that major arc, there's a few ways that I could do it. Knowing that a full circle is 360 degrees, I see that I don't do quite a full circle. I do 360, which would be the full circle, but I don't include that 110. So that leftover major arc must be 250 degrees. I could also do this by adding some pieces together. I know since I've got a semicircle, that's 180. I know that subtracting would get me 70 degrees for this piece, and then adding those 2 green pieces together, 180 plus 70, is another way I could also get 250 degrees. For this problem on the bottom, I'm going to have you pause the video and try a few of these, or try these on your own. I'll kind of get you started though. One hint I'll give you is that maybe we want to find this missing piece right there. Well, knowing that all 4 pieces need to add up to 360, I can subtract to find that this piece is 100 degrees. And so what I want you to do, like I said, is pause the video. First, go ahead and label what you believe these arcs to be, whether they're minor, less than 180, major, more than 180, or a semicircle being equal to 180. And then go ahead and find out how many degrees you have by adding certain pieces together. My answers will pop up in just a moment. So there are the classifications I came up with, as well as the angles. If you did not get any of those, go ahead and double check your work or ask me in class. And then lastly, for this video, we have an application problem. In this case, we have a bridge that's rotating to open up. And what the problem tells me is that the bridge rotates 60 degrees in order to be fully open. To help figure out what this problem, or what we're going to do with this problem, imagine if the bridge were able to open all the way around. We can see that the shape we would form is a circle, and that bridge would form the radius of the circle. So once again, we have a central angle, which tells us the x, the angle of that arc, is going to be equal to the angle, that central angle. So this is going to be an arc of 60 degrees. And then our application step down here, they say, well, suppose the bridge opens at a rate of 20 degrees per minute. How long will it take to open up fully if we say that 60 degrees is fully open? So in this case, all I'm doing is figuring out how many times 20 degrees, my rate, goes into my angle of 60 degrees. So dividing those together gets me a time of 3 minutes for the bridge to be fully open.